We're going to talk about right triangle trigonometry and look at the definitions of the 6 basic trigonometric functions that you're going to be dealing with throughout the semester. If you'll recall, the word trigonometry itself literally means measurement of triangles. And trigonometry is used in a variety of fields. One, it's used in navigation to help set directions for planes or ships. It's used in construction to help measure a particular field or lot to determine the slope of a roof, the height of a building, and even structural loads. It's actually even used in biology in the study of the structure of DNA in today's world. It's also used in what's called cartography, which is the creation of maps. The trigonometry can be used to determine the heights of mountains or different land features. So let's review for a minute. We have our right triangle, and one of the differences that you have here as we begin focusing on the right triangle trigonometry is you have to focus on the angle that you're interested in. You have kind of a focal point, and typically that focal point is named theta. Okay, it's usually written kind of in the little bend of the angle. It doesn't have to be theta. That's probably the most common one, but there are other letterings that can be used. We could even use capital letter A to name the angle, but that becomes, this angle here becomes basically your point of reference. And so the sides and angles are all named or labeled using this particular angle as your point of reference. So the hypotenuse, it never changes. The hypotenuse still is going to always be across from the right angle. You're still going to have notation that the right angle, where it's located in the particular triangle by the box in the corner, and again, it points in the direction of the hypotenuse. Okay, so it's all, the hypotenuse is always across from the right angle. The legs or the sides of the triangle are again named in reference to your angle or your point of reference, which in this case is angle theta. And so if you look in reference to angle theta and you look across or opposite from that angle, you have the side opposite to that angle. Okay, so this is the side opposite. It's actually the leg. Okay, it's leg A if you want to think about it, but it's opposite our angle, which is our point of reference. Then you have the angle that is next to the one, you have the side that is next to the one that you're interested in. So you have your angle, which is your point of reference, and then next to it, or the word is adjacent, it's next to the angle. So we talk about, in terms of the triangle, we still have the hypotenuse, which is the side opposite the right angle. And then the other sides, we talk, other legs, we even talk about them being either opposite the angle or adjacent to the angle. And you have to pay attention to the point of reference. And this holds true regardless of the orientation of your triangle. Even if my triangle is kind of turned in the other direction, okay, I still have my right angle. Okay, so across from the right angle is my hypotenuse. And then if I have, I'm interested in angle theta. Okay, here's theta. In this case, the side opposite or across from theta is this one. And then adjacent is the one next door. Okay, your triangle can be, so the orientation doesn't matter. You have to pay attention. But notice, let's see if I draw that same triangle oriented in the same way, but instead my focal angle is in the other one. So now that I have this focus angle. You still have your hypotenuse, which is opposite the right angle, but now the side opposite and adjacent. So you have to pay attention to the orientation, and I would encourage you to actually do the labeling on the triangle. Now, there are 6 different trigonometric functions defined for the right triangle. Okay, and so we're going to take a look at those 6. The first one is called the sine, and we abbreviate sine, S-I-N, and then you have your angle. So the sine of angle theta equals the ratio, or the fraction, if you want to think about it as a fraction, the ratio of the opposite side to the hypotenuse. Cosine, which is abbreviated COS, the cosine of the angle is the ratio of the adjacent side to the hypotenuse. The tangent, which is abbreviated TAN, it looks like tan. The tan, or the tangent of theta, is the ratio of the opposite side to the adjacent side. And then you have 3 more. You have the cosecant. Okay, cosecant is CSC. So the cosecant of theta is the ratio of the hypotenuse and the opposite side, excuse me. You then have secant. Secant is abbreviated SEC. And so the secant of theta is the ratio of the hypotenuse to the adjacent side. And finally, you have the cotangent, which is abbreviated COT. It looks like cot. COT. So the cotangent of theta is the ratio of the adjacent side to the opposite side. So each of these are ratios or fractions, and you're relating 2 of the 3 sides, and there is specific relationships for each one. One thing I want you to notice, though, I've got these lined up in 2 columns on purpose, because if you'll notice, sine and cosecant, notice that, let me back out of here for a second so I can do some markings for you. Notice that with sine and cosecant, for example, for sine, the opposite side is on the top, and in cosecant, it's on the bottom. And the hypotenuse is in the denominator for sine, but it's in the numerator for the cosecant. Basically, it's a flip. They've been flipped over. The mathematical term is they are reciprocals. So sine and cosecant are reciprocals of each other. It also holds true if you look at cosine and secant. It does the same thing. They are reciprocals of each other. It's a flip. It's another way to think about it. And tangent and cotangent are also reciprocals of each other. Now, I point that out to you because here's the deal. If you can learn these first 3, if you can learn the relationship between sine, cosine, and tangent, and remember that the other 3 are the reciprocals, then you really only have to memorize or learn 3. The other thing that I'll point out to you here is notice how you have one of the functions is just like plain old sine. The other, its partner function, has a co. So you have sine and cosecant. You have cosine and plain old secant. You have tangent and cotangent. So the partners, the ones that are reciprocals of each other, you have one that says co something and the other one does not. Now be careful, because a lot of students want to put sine and cosine together. Okay, so be careful about that. But your 3 basic ones are sine, cosine, and tangent. And if you can learn those and then realize that the remaining 3 are reciprocals, that's going to help you out. A couple other quick notes about dealing with right triangles. Remember that right triangles have one right angle, which is typically indicated by the box in the corner. The other 2 angles are acute, which means they measure less than 90 degrees. And because of that fact, because each that you have those 2 acute angles, the trigonometric function is going to be positive. Okay, so you don't have to worry about having negatives here. Another note about the right triangle is that the hypotenuse, which is the side opposite the right angle, is always the longest side of the triangle. I already pointed out to you that the ratios in the second column are reciprocals of the first. And again, I've enumerated those for you. And then finally, the size of your triangle really doesn't affect the trigonometric function, okay, or the value, because the trigonometric function depends on the angle measure, not the size of the triangle. So you can have a really, really tiny triangle and a really big triangle, and they could still have the same value for the trigonometric relationship. A couple of memory devices that sometimes help students remember at least the 3 basic trig functions: sine, cosine, and tangent. You may have heard some of these. One is, probably the most common, is SOHCAHTOA. Okay, SOHCAHTOA. It's pronounced SOHCAHTOA. And it represents sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So it gives you a way to remember the 3 basic trig functions. Another one I kind of like a little bit better is some old hippie caught a hippie tripping on acid. And again, if you look at the first letter of that, each word in that phrase, you get the relationship. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Another one I saw in a textbook at one point said, some old hog came around here and took our apples. Again, it gives you the relationship. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, so it gives you those relationships. Okay, so you want to be sure that you learn at least those 3 basic trigonometric relationships, and remember that the remaining 3 are the reciprocals. And we're going to look at how to use those to solve basic right triangle problems in another video.